Hey everyone, hope you're all having a great and fabulous day. Today we are going to relate what we can actually do with the quadratic formula. A lot of you may think that, when am I ever going to see this? But in all honesty, like this is one you may see a lot, and it relates a lot to everyday life. But I first have somebody that wants to say hi. She has her snack and her bubbly. So she is ready to go to learn vertical motion model. That was Brianna. I have her right next to me. She's watching. So she's going to learn with you guys today. All right. So it says many real life situations follow a parabolic path or the path of a quadratic. Like any object that is thrown or dropped, the equations below can be used to model the path of the dropped or thrown object. Okay. So these two equations right here are two equations that you will use anytime that you have a throw or drop problem. Okay, the only difference is that one has this VT, and VT has velocity, which means there's a force. So, like, think of when you throw an object, you have to, like, put effort into it, right? Where you just drop something, all you do is let gravity take over, okay? So here's what each variable stands for. H is your ending height, where the object ends. T is time. That's the one we're always going to be solving for. V is velocity. That's the one that if it is thrown, it has. And S is starting height. So let's take a look at an example. It says you dive off of a 15-foot diving board with initial upward velocity. Okay, upward means positive, of 3 feet per second. How long will it take for you to hit the water? Okay, so the diving board is giving you a force, which means it's going to give you a velocity. So that's V. Okay, let's do that one first. Upward velocity means it's going to be a positive 3 feet per second. Okay. The height of the diving board, the starting height, S, is 15 feet. And the ending height will be 0 because that's when you hit the water. Okay. So we're going to use the throw equation. You're going to use the throw equation. So it's going to be 0 equals negative 16t squared plus 3t plus 15. Okay, again, all of these numbers I'm getting from this throw equation up here. So let's solve it like we have been the last couple days. Okay, my A value is negative 16. My B value is 3, and my C value is 15. Okay, so I'm going to use my quadratic formula. X equals opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, so if you simplify what's underneath your square root, if you type that into your calculator real quick, you're going to get 969 all over negative 32. Okay, at this point, this is where we split it into two equations. Okay, actually I'm going to zoom in a little bit. This will be easier. I'm going to zoom in. Okay, so you split it into two equations, negative 3 plus the square root of 969 divided by negative 32, and negative 3 minus the square root of 969 divided by negative 32. Okay, my final answer is going to be negative 0.88 or 1.07. Okay, now since we are talking about actually diving on the diving board and we're talking about time, only this right here is going to be a possible solution. Okay, because you cannot have negative seconds. You cannot go back in time. So your final answer would be 1.07. Now you probably are asking, why does she have her calculator out? Well, solving by this is easy and all, but solving by graphing is so much easier. Okay, so we are going to graph this on our calculators. So go ahead, take out your calculator if you haven't already, and go to y equals. In y1, you're going to put your equation. Negative 16x squared. Okay, there is no t button, so you're just going to use x. It's the same thing. Plus 3x plus 15. Okay, in your y2, you're going to put 0. This is something that we have done so many times. Okay, I'm going to make my window a little bit bigger. Okay, I'm going to make it negative 30, 30, and then I'm going to make this, I'll keep this negative 20, and then I'll make this one 20. Okay, so go ahead and hit graph. I just zoomed out. This may have been a little too far, which is okay. Really, it looks like this. Okay, this would be 15 feet. This is where the diver hits the water. Okay, so we hit second trace 5 because we're looking for an intersection. Enter, enter, enter. And again, if you look real closely, it says 1.066, which if we round to the nearest hundredth, it'd be 1.07 seconds. And again, we cannot go into the negatives. Okay, so either way, you're going to get the same answer. I'm going to change my window on that in a second. So here's another one. It says Ronald McDonald drops a flower pot from his window at a height of 250 feet. How long until it hits the ground? So the starting height of the flower pot is 250. The ending height is ground. Ground is always 0. Since he is just dropping the flower pot, there is no velocity. Okay, so this is going to be the other equation of dropping. So your equation is your ending height equals negative 16t squared plus 250. So if we were to solve this algebraically, a is negative 16, b is 0, and c is 250. Okay, but without that middle term, you can actually just solve. Okay, when you don't have this, technically you're pretty much going to have one answer. So you have 0 equals negative 16t squared plus 250. When you get, and again, you don't have that middle term, you just subtract 250 from both sides. Divide by negative 16. So you get t squared equals 15.625. And then you have to square root. Remember, you have plus or minus in your answer when you solve by square root. And it would be 3.95. But again, since we're talking time, your answer is only going to be the positive 3.95 seconds. Let me show you how much easier this is to do it graphically. So again, I told you I'm going to change my window. I'm just going to zoom 6 it back to normal. Okay, so we can see it a little bit better. So I'm just going to change my y1. My y2 will always be 0, or if it changes. That's always where my ending height is. So negative 16t squared plus 250. My ending height is 0. Okay, I'm looking for this intersection right here. Because this is my negative, I need my positive. So second trace 5, enter, enter, enter. 3.95. So this looks like this. Here is 3.95. Where the flower pot hits the ground when Ronald McDonald drops it, it will take 3.95 seconds. All right, here's another one. While at baseball practice, Joe throws a ball up into the air. Up is a positive force. Okay, the starting height of the ball is 4 feet. The ball travels at 20 feet per second, and then Tom catches the ball at a height of 5 feet on its way back down. How long until Tom catches the ball? So, my starting height of the ball is 4 feet. My ending height is 5. So he must release the ball at shoulder height, bring up his glove, and catch it above his head. Since it is up, it is going to be a positive 20 feet per second for the velocity because that's how much force he is putting behind it. Okay, so we always write ending height equals negative 16t squared plus 20t, that's my velocity, plus my starting height 4. Okay, what we're going to do is we are just going to graph this. We're not going to use the quadratic formula. So go ahead, go back to y equals. In y1, we're going to do negative 16t squared plus 20t plus 4. But this time our ending height is not 0, it is actually 5. So let's see what this does. Go ahead and hit graph. So notice it passes twice. Okay, but he releases the ball and he doesn't catch it right away. He lets the ball go all the way up and comes down to catch it. So we're going to do second trace 5. But this one, you actually are going to have to move your cursor towards the second intersection point. So here we have our ball goes up and then down and then at 5. So show your 2 intersection points. This is the one that we want to graph. So it takes 1.20 seconds for him to catch the ball. So Joe's name went from Joe to Tom, so I apologize. But what happens if Tom missed the ball at 5 feet? Okay, so he was like, I got it, got lost in the sun. He misses the ball, and now it hits the ground. The only thing that changes in our equation is going to be this 0. Okay, the ball now hits the ground. It doesn't get caught at 5. The equation stays the same. So when we do this, we're only going to change our y2 back to 0. So now you do second trace 5, enter, enter, enter. Oh, that's the wrong one. Second trace 5, arrow over to our second and it would take 1.43 seconds for the ball to hit the ground. All right, again, we're only using the same 2 equations. It's just you have to figure out what to do. Okay, walking through Central Park, I was down on my luck, so I saw a wishing fountain. I pulled out a penny out of my pocket and I threw it down. I said, I am so mad, I'm going to just throw this in there. I'm not going to flip it with my thumb because I don't know how to do that. So I'm just going to throw it down because this better work. If I threw it at a downward velocity of 20 feet per second, I stand 5.5 feet off the ground. How long would it take to reach the bottom of the well, the wishing fountain, ignoring water resistance, everyone? So my starting height is 5.5. My ending height is 0 because it's the ground. My velocity is going to be a negative 20 because I'm putting a downward force on it. I am throwing it straight down. I did not let it go all the way up just to come down. I am literally throwing it down. Okay, so my equation would be 0 equals negative 16t squared minus 20t plus 5.5. Okay, so here, let's try this again. We have negative 16 x squared minus 20x plus 5.5. I'm going to leave x or y2 as 0, and I'm going to hit graph. So notice how you can kind of see that it's from here, it's going straight down. Okay, so again, we're just going to do second trace 5, enter, 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 and it takes almost not even a quarter of a second. So my graph, it looks like this, and then it comes straight down. Okay, so right here, it would take 1.20 1.5 seconds. Or sorry, 0.15. 0.15 seconds. Yes. I hope I put that in right because my answer key. No, it's not. Look at this. I was going to say my answer key is different, so I hope you guys are saying, no, you're wrong. Let's try this again. I was going to say my answer key is completely different from this. There we go. That looks so much better. Second trace 5, enter, enter, enter. It is not 0.15. It is going to be 0.23. Okay, I apologize. I put in my problem. All right, I got a couple more for you. Okay, it says Jenny drops her keys from her window 50 feet above ground to her friend Steve, who was in a window 30 feet above ground. How long until Steve catches the keys? So the keys start at 50 feet, and Steve is at 30 feet. Okay, since she is dropping the keys, there is no velocity. So this would be 30 equals negative 16t squared plus 50. Okay, using the dropped equation. Let's see how long it's going to take Steve to react to get these keys. So plus 50, and he is at 30. Now our window does not have that, so let's open our window. We're going to change our Y max. Let's change it to 35 because it needs to be a little bit bigger than what is in our equation. There we go. Okay, so here's that intersection. So clearly he's going to have a chance to catch it. So second trace 5, enter, enter, enter. So Steve, it looks like this. So Steve has 1.12 seconds in order to react and get the keys. Now, what happens if Steve does not get the keys? Okay, he's like, I missed them. So how long does it take for the keys to hit the ground? So again, the only thing we're going to change is this 30 to 0 because he missed the keys. Now they're going to the ground. So if we do Y equals and change that to 0 and hit graph, you're going to hit second trace 5, enter, enter, enter again, and it will take 1.77 seconds for the keys to hit the ground. All right, I'm going to go all the way down to Chris. Chris is at a Bulls game. Benny the Bull is shooting t-shirts at a crowd with a t-shirt slingshot. If Benny is standing on a 10-foot high platform and is shooting t-shirts at a velocity of 20 feet per second, will Chris be able to catch the t-shirt if he's 40 feet in the stands? Okay, so our ending height is 40. Chris is 40 feet in the stands. Benny is 10 feet off the ground, and his t-shirt gun is shooting with a velocity of 20. It is shooting upward because it's trying to get Chris. Okay, so our equation would be 40 equals negative 16t squared plus 20t plus 10. He's starting 10 feet off the ground. Okay, I want to know, will Chris get a shirt? Or will he have a chance to? So here we have negative 16t squared plus 20t plus 10 with our ending height at 40. Okay, so we do need to change our window. Let's change our Y max because we need to see higher. Let's look at 50 and hit graph. Whoa! He's not even going to get close, right? So because our graph looks like this and Chris is way up here, this is going to be, no, it will not reach him. Right? It will not reach because the t-shirt cannon does not have enough velocity. All right, so I will be back tomorrow to do more problems with this with you. Please make sure that you are doing your homework. It is worksheet. Hang on, I gotta look it up. 6. So you have plenty of time to do worksheet 6. I will be checking 4, 5, and 6 tomorrow.